and you are required to plot a graph. Let's briefly remind ourselves some little bit of graph work. And usually, in biology, commonly we use line graphs. And when we are joining the points, by the way, we don't use rulers. If you use a ruler, you lose marks, you lose everything. So let's see. It is the most common type of graph that is used in biology. And these ones, they show how one or more variables can change over a continuous sorry, so this is variables. That was a misspelling. Let me change that. Let me correct that. Yes, I've corrected it. It's variable. So they show how one or more variables, and which variables, by the way, the dependent variable, change over a continuous variable. Mark this word. A continuous independent variable. Okay? The keyword here is continuous. So this therefore gives us the continuous data and the discontinuous data. Now, for the discontinuous data, here we use a line graph. Now, what do we mean by discontinuous? Here, a given factor has changes in the parameters, and these changes, they don't show any discrete. They are not discrete amongst themselves. For example, take for instance temperature. If you say 0 degrees Celsius and you say 1 degree Celsius, we have a lot of values between 0 degrees Celsius and 1 degrees Celsius or 1 degree Celsius. There are a lot of values, between 0 and 1 degree Celsius. So that's what we refer to as a continuous data. But for the discontinuous data, the two or more parameters, they show completely discrete. They are discrete in nature. Whereby if you have, for instance, A, this is A, and this is B, the two parameters of a given variable, A and B, variable, the two parameters A and B, they totally have no relationship. And there is nothing here that binds these two. So if you have such data, then that data is known as the discontinuous data. For example, you are plotting number of people in a given area, and you have males and females. That data between males and females is discrete, is discontinuous. So when you are plotting, you cannot use a line graph. You join the males. No, you cannot use a line graph. Okay? But when you are plotting, for instance, height, okay, of individuals in a given locality, then you cannot use a bar graph. That's madness. You must use a line graph because one is continuous data and the other one is a discontinuous data. And so for such continuous independent variables, we use a line graph. Okay? But it doesn't rule out. I'm quite sure that throughout your entire education, you've been drawing line graphs, that if by any chance somebody sets a bar graph, you'll be knocked off. So in today's lesson, or in this chapter, I'm trying to correct that. I'm trying to rule that out. there is a possibility of giving you a bar graph, and you analyze such a bar graph. But in whatever case, you just look at the trends and relationships in the patterns that are depicted in such a graph. Now, let's look at some basic skills that we need to plot a graph. The first thing you do is you locate the axis. And the axis, in this case, is either the y axis or the vertical axis. Vertical means erect or standing. And on the y axis, we put there the dependent variable. Somebody asked that question. Now here is the answer to that question. On the vertical axis or on the y axis, we put the dependent variable. And on the x-axis, that is the horizontal axis, we put an independent variable. Okay? The one that can be manipulated. If I find you having a graph where you have the independent on y and the dependent on x, I'll just be like, man, damn it. Okay? And your axes must be well labeled. Let's see. This is our graph paper. Okay? And the graph paper, I had to put this. If you have a graph paper and you have a ruler by your side, just measure from here to here to here to here. You find out that actually from here to here, that's actually 1 centimeter on a ruler. From here to here is actually 1 centimeter on a ruler. And so these two boxes, they actually represent, they are actually 2 centimeters in actual measurements. So that one rules out the issue of writing a scale. Obviously, you're going to put a scale just here, and you put your title just here, but within the grid. Okay? Now, most of you, or some of you, when you're writing your scale, you'll be like, one small box. And now the question is, I'll ask you, what is the small box? Are you meaning this one because it is also a small box? Are you meaning this one because it is also a small box? Or you're trying to mean this? Or this, what is your one small box? Well, this one can also be a one small box, because you can't convince me that this is one big box. Because if this is a big box, then what will be this? Get my point? That's brilliant. So don't be tempted to write one small box. There is nothing like one small box. But because these two, they are equivalent to simply 1 centimeter, then write 1 centimeter. Now the mistake most of you guys make, you want to show us that you've studied enough physics. You want to show us that you've studied enough chemistry. And then you be like 1 centimeter, and then you put dot, colon, and then another colon, and then you write what it is. I'll give you a smiling cross. For some of you even want to show us that you are tired, and be like 1 centimeter, and then you write rape. Have you ever heard of anybody raped by 1 centimeter? 1 centimeter doesn't rape when you're writing your scale. And I will show you how we get the scale. Okay? So you write full words. Write your scale as if you were a reasonable person, a responsible person. Okay? Just come, don't draw a box. Just come, say vertical scale. You can write the word vertical, you can simply write VS. and you put semicolon or you underline, and then you write 1 centimeter represents, write full word, represents, and then you write your scale with correct units, well stated. And then you do the same for a horizontal scale. Okay? You put your units, try to be neat. And so 1 centimeter represents. Try to be neat as possible. Represents. Okay? And then you write your scale with the units. Sorry? With units. If anything is missing here, then we shall not mark. Then you have your title somewhere here, and then you label your axis. And axis must be well labeled. With a 0, you can draw something. They cross each other like this. Since the data is continuous, then these axes must have arrows. If you don't put one, if you don't include the arrows, then we shall cross you. And you put your dependent variable here. You write it well, slanting, it's okay, no problem. Your dependent variable here, okay, in units. Now, most of you, the mistake that you make in units, you put the units. Now, most of you, the mistake that you make, you want to put this in brackets and do this. This is the independent variable. Independent variable, and you want to do this, and then you put brackets and put the units in brackets. Now, on a good day, we cannot mark this. Actually, we cannot mark, because since P1 have been told that when you put in brackets, it means multiply. If you put in brackets, it means multiply. So here you are getting your independent variable and you are multiplying it. We shall not mark. If you find some strict examiner, he or she shall not mark. The same applies to this. You put your independent variable, or you put your variable well stated, and then you be like slash, and then you put the units. On a good day, we shall not mark. Okay? It is simply the variable, and then you put in the units. That shows that that variable is measured in that unit, in such units. If it is a arbitrary unit, put your arbitrary units. If it is in ppm, then you put carbon dioxide concentration in ppm, in parts per million. Yes?
Yes.
If it is dry mass, then you put dry mass of crops in grams. Don't put G in brackets. If you do that, I'll give you a smiling cross. And usually you advise to leave two boxes. This side and 2 boxes down. So that one box is for calibration, is for putting values on the axis, and then another one is for labeling that axis. Okay? Yes. Now let's see other qualities of a good graph. Your graph must have a title. And the title should be as brief as possible. As brief as possible, but it should have all the information that I need, that if I just need to Just look at your title and I know what the graph is about. You can write in capital letters, you can write in small letters, you can underline, you can decide not to underline. Whatever the case, the graph must have a title, brief as possible, but as elaborative as possible. And so in order not to give you headache, I've gotten you some tips on how to write a good title. And the tip is one. We are going to substitute the actual names of the variables, the independent and the dependent variables, into the following statements. Number one, your title shows a graph, or it's for the graph which shows variation of the dependent variable with. You vary with. Variation is the same as change. So someone can say a graph showing change. But for me, I prefer variation. It's all the same. So it is variation of the dependent variable. If you write this first before this, I'll cross that title. That title won't make some good sense. It is dependent varying with the dependent variable. No units in the title. Don't bother, don't even get tempted to put units in the title. That is one skeleton. Another skeleton is, in case variation becomes hard, you can use relationship. It is also okay. And it's the relationship between the dependent variable and the independent variable. No units. Don't say relationship with. No, we don't have relationship with. Go and read your prepositions. English. Go and, I'm not an English teacher. We don't have relationship with. It's the relationship between this and this. You don't vary and, you vary with. It's a variation between, it's a variation of this, the dependent variable, with the independent variable. Or when this becomes hard and you completely get lost, then you can also write such a title. A graph which shows the effect of the independent variable on the dependent variable. That one also, on a good day, it can be marked. Let's try to formulate a title here. So I have this is our example. This is what we've been following right from the beginning. And here we have carbon dioxide concentration of carbon dioxide in ppm, in parts per million, like how you can say. And then here we have average dry mass of the plant. So can you try to formulate your title? In case you are watching the video, pause and formulate your title. So formulate your title using any. Actually, you can start with variation, and then you go to relationship, and finally you go to the effect. But I prefer this. Okay? I prefer this. So, yeah, that was good work for some of you. That was really good. So, you have carbon dioxide concentration in parts per million, and then the average dry mass of corn plant and valvate leaf plants. I will show you the two plants, I guess. No, you saw them. So you simply say a graph showing variation of the dependent variable is this, the average dry mass of one cone plant and one valvet leaf plant with carbon dioxide concentration. As simple as that. We can say a graph showing the relationship between the average dry mass of a cone plant and a valvet leaf plant and carbon dioxide concentration. You can simply say a graph showing the effect of carbon dioxide concentration on the average dry mass of a cone plant and a valvet leaf. So that title is really good, that I can read it and simply understand and get to know what your graph is about. And it's brief. And so guys, yes,